So it's time for us to start talking a little bit more about addresses of objects in memory. And before we continue, I'd like to tell you that this printf function is using the so-called format string, which essentially sends this text out to the console window. Let me run it again. I press Control 5 to execute this function right here, and you see that it prints this text, and then %p is an indicator or format character inside this format string that printf understands, and it's using this as a placeholder for or to display the value that we provided as a second parameter for this function call. So I told you already that obtaining address of the variable is very simple. You just add ampersand in front of it, and this will return the address of the variable. So this is the address of my variable x in memory, and remember, it's located right here in the stack area because of course x is a local variable, variable local to function main. So this is a C style coding because printf is a function, or it's also named as a formatted print. It's a C style output. A C++ style of output would look like this. X is stored at, and then address x, and then new line character. Okay, so basically this is a C++ style output. For myself, I find a C++ style more convenient because I can focus more on individual items that I'm trying to print using this output operator that is sent to character output device, which is our console window, just like this. And to be able to compile it, you can see that printf is declared and defined in this library header. For cout, we already did this earlier. We need another include, which is named ios3. Okay, so I will build this and run this program one more time, and you can see that now here I printed twice, once using printf and the second time using character output device cout, which is a C++ type of output. So to let you know, my preference and my choice is always to use the second style, but a lot of C programmers use printf. Whichever way you do it, it doesn't really matter, but standard C++ is probably just would recommend you using a cout type of output. And as a general recommendation, in the same program we tend not to mix C style and C++. You just follow one or the other. Either you start using printf or you start using cout, because it may involve some tiny issues with buffering of these characters before they're sent to the output console, and there's some other issues that may be involved. So typically we don't want to mix them in the same program. Just choose one or the other. And like I told you, my choice is to use character output that comes from this second header. So here, good question. Why does %p, which is pointer type of output inside this formatted string, or to repeat this question, why cout when it sees the address of the variable, why they both display this address as a hexadecimal number. Well, it's just the way engineers typically refer to memory addresses. Now look, the memory space is pretty big, right? So it's not just 14 or so locations. It's actually 4 gigabytes in the space of 32-bit program, and 1,000 times more in a 64-bit program. So therefore, unique memory addresses given to individual variables are not specific in any way. They will change with every time the program executes itself, placed somewhere in memory. So we really don't care about memory addresses, rather than trying to look at them when we debug our program, or when we try to understand the certain data structure in memory and things of that nature. In other words, memory addresses are pretty low stuff. It's not mainstream stuff. You don't display these addresses to the user. You really don't need to store them in your database or anything like this. These are just dynamic, unique locations identifying places where exactly in memory our variables are stored. So for instance, if this variable x is stored somewhere here, there you go. We have this unique address that essentially is telling the compiler that this variable is stored at this memory location. So instead of 12, it's A, F, F, B, 8, and 4. So this is just a unique identifier of rather big binary number that right here identifies this specific memory location. So let's elaborate a little bit more on hexadecimal numbers, their structure, and why do we use them, and why they are chosen to be used when we deal with memory addresses.